All right, guys, so as we close out chapter 5, I have this project for us to work on. I say all the time that when my students ask me when am I ever going to use this stuff, the correct answer is maybe you won't. I'm your high school math teacher. You can focus on that stuff when you get to college and you really isolate what you want to do. If you want to write for the Boston Globe, I don't know that you'll necessarily be using the Pythagorean theorem or stuff like that. It's not really the point, right? But I try as often as I can to ground what we do in some sense of reality so you know that it's not totally useless information. Okay. So with this project, I want to try and ground what we've been talking about, the triangles, in some reality. So the first thing that I have everybody do for this project is you got to put together like a toolbox, some type of formula sheet for us to use. Some of the essential information that you're going to need handy to complete this is you're going to need to know the midpoint formula. You're going to need to know the distance formula. You're going to need to know how to write equations of lines. You're going to need to know how to solve for points of intersection. These are all things that we've covered already. And you need to have an understanding of the different features of triangles that we've talked about. Angle bisectors, perpendicular bisectors, where they meet, and why that's important. So here's your situation. You work at an engineering firm. Tufts University is going to start a major new project. They're going to spend millions and millions of dollars on a new student center. And in that student center, they're going to put some new, 5G router, and it's going to give Wi-Fi to the entire campus. Big investment, big way to get kids to come to school there. They want to make sure that they do this right. So when they purchase a property to knock down and build this new student center, they want to make sure that that location is going to be able to get Wi-Fi to the freshman dorms, to the library, to the off-campus housing. So they need to find a property that's equidistant from all three of these locations, and then select the router with the radius large enough to reach all three of these locations. You're on the team that's going to look at what are the best properties for you to choose. All right, now I've obviously oversimplified this a lot, okay? But that's a general idea. If you were doing this, this is actually something you would have to do. So let's take a look. This is an actual map of Tufts University. So what would I be asking you to do? Or what would you be being asked to do at your company? If they told you that off-campus housing is here, and they told you that the library is here, and that the furthest away freshman dorm is here, you need to find a property that's going to be equidistant from all of these places. So let's think about this. Oh, Mr. Card, it's a triangle. So I'm looking for a place somewhere in here where the distance here is the same as the distance here, is the same as the distance here. What do we know of? What have we learned about in this chapter where three lines meet at a point that's equidistant from the vertices? Hopefully, you're going, oh, I know. The circumcenter. The circumcenter, because it's equidistant from all these, actually allows for you to circumscribe a circle that I'm obviously doing a terrible job of around those points. So if the student center was here and we picked a router with a large enough radius, we'd get all these points. That's pretty good. All right. But how do we find this circumcenter, Mr. Card? Well, you should understand that circumcenters come from perpendicular bisectors. So if I could find all three perpendicular bisectors, I would know the location of my student center. So what process do I expect you to follow? I expect you to, once I give you some coordinate points, again, I'm oversimplifying it a bit, all right? I'm expecting you to find the three midpoints. That's where you need that midpoint formula. I'm expecting you to find three perpendicular bisectors. How are you going to do that? Find the equations of them. Now, we know how to do that. If you're given a point and you need to find a line that's perpendicular, you know to take the opposite reciprocal slope of the actual, space between if the dorm's here and the library's here. That line will have a slope. You'll then run a perpendicular bisector that is an opposite reciprocal slope through the midpoint. And when you do that 3 times, they'll all meet. So that third step is solve. If you have 2 of these and you set them equal to each other, you will be able to find the y value and then reverse find the x value. Or sorry, find the x value and then reverse find the y value. Okay? And then I'll ask you to do some other stuff. Okay, what's the actual radius? Right? Like how big actually, what actual router power do I need? And that's, you're going to use the distance formula. Right? So these are all things that you know how to do. I know I've taught you how to do. Heck, some of the stuff you learn in Algebra 1. So I give you these points. And I want you to make sure that every step that you go through, you're updating your coordinate plane. If I tell you that the dorms are 8-8, the library is 8-2, the off-campus housing is 4-6, can you plot those points, and as you go through step by step, can you find that circumcenter? And we're going to take time in class to allow you to work step by step through this. I hope you guys appreciate this. I hope you see it as a different way for me to assess you guys. I hope this grounds what we're doing in a little bit more reality. And I hope this video helps you through the process.